Since the dawn of our existence, we have witnessed the sun rising above the horizon, bathing the Earth in its light and warmth. We know precisely what it looks like as it passes through the blue sky above. We even know what it looks like from the position of other planets within the solar system. But what does it look like up close? What do we see when we peer at the surface of the sun? As the only star we can observe in detail, the sun provides a basis for our understanding of other stars. And the better we understand other stars, the more we know about the Milky Way. In recent years, NASA has succeeded in touching our closest stellar neighbor when its Parker Solar Probe flew through its hostile atmosphere and captured this incredible time-lapse footage. The footage was taken during the probe's closest approach, revealing streaks of electrically charged gas and plasma called coronal streamers, a small example of how bizarre the sun becomes the closer you get. But we don't necessarily have to travel to the sun to study it. For decades, astronomers have used multiple tools, including ground-based telescopes and Earth-orbiting spacecraft, to examine its mysterious, scorching layers. The sun is a giant sphere of unimaginably hot plasma. It has no solid mass, meaning it doesn't have a distinct solid surface like the Earth. Instead, it is composed of layers made up almost entirely of hydrogen and helium, and so the surface of the sun is considered the first visible layer. The light that bathes the Earth during the day originated deep within the core of the sun and is created during a process called nuclear fusion. Light is made of particles called photons, which bounce around within its interior, gradually working their way outwards while colliding over and over again with atoms. After tens of thousands of years, photons will reach a level where the plasma is less dense, allowing them to escape into space. And it is this level that is commonly referred to as the surface of the sun, a layer called the photosphere. Although we call it the surface, the photosphere is actually the first layer of the solar atmosphere. It is the deepest layer that we can directly observe. It is about 400 kilometers thick, which is 250 miles thick, making it relatively thin considering the overall size of the sun, which accounts for 99.86% of all the mass in the solar system. It reaches scorching temperatures of above 5,500 degrees Celsius, which is 10,000 degrees Fahrenheit, making it hot enough to melt diamond. This magnificent footage is of the sun's surface, revealing in unprecedented detail dynamic cell-like structures, moving and evolving in shape and size. What you are viewing is the last layer of the sun before light escapes into space. At this point, photons are already thousands of years old before being released in all directions, some of which make the 8-minute and 20-second journey to Earth. The footage was captured using the Daniel K. Inouye Solar Telescope and is currently the highest resolution images of the photosphere taken so far, revealing details as small as 18 miles, which is 30 kilometers. The reason the photosphere seems like it's bubbling is because hot plasma from within the sun rises to the surface, cools, and sinks back down in a process called convection. The same process can be seen when water is bubbling in a boiling pot, for example. Hot, new, rising plasma is visible in the bright regions, while the dark edges is where it cools and sinks back into the sun's interior, and each cell is estimated to be around the size of Texas in the USA. Sparsely scattered around the photosphere are also enormous dark features called sunspots. These planet-sized regions appear dark because they are much cooler than their surroundings, roughly 2,000 or 3,000 degrees cooler in fact. Sunspots are caused by disturbances in the Sun's powerful magnetic fields, which are so strong they keep some of the heat from escaping and reaching the surface. The magnetic fields are very active, often tangling, crossing and reorganizing, while frequently causing sudden, powerful explosions of energy called solar flares. Sometimes, the flares are also accompanied by coronal mass ejections, which are huge bubbles containing billions of tons of charged particles, blasting out into space at extremely high speeds. These massive bursts of energy are spectacular to observe, as this footage reveals. They are, after all, the solar system's largest, most explosive events. Although we see the sun every day shining in the blue skies above, it's only relatively recently that we have had the technology and know-how to peer past its powerful glare and study its bizarre bubbling surface. By better understanding the photosphere and monitoring the magnetic fields, astronomers can predict when potentially dangerous solar storms will occur, which can disrupt satellites and power grids on Earth. Not only that, but they can also test theories about the Sun and attempt to answer some of its biggest mysteries.
$13.8 billion years ago, something incredible occurred. The Big Bang. The moment when space and time were born. The beginning of the ever-expanding existence that we call the universe. Everything we can touch, feel, sense, measure, or detect is the universe. From the tiniest particles, to the largest galaxies, to the very existence of space, time, energy, and life. The beginning of the universe is the beginning of everything. In a way, we are a small part of the universe attempting to understand itself as we peer out into the unknown and observe the wonders that it has to offer. We have been able to discover extraordinary things from Earth, but now we must leave our blue planet and explore the farthest reaches of the cosmos.